Music is built on mathematics. Every note, every harmony, every rhythm follows hidden structures and ratios. But why do these vibrations in the air move us so deeply? Sound surrounds us every day, but did you know it behaves in ways that might surprise you? Stick with us and let's break it down.
Over 2,600 years ago, Pythagoras made a profound discovery. He found that the simple act of plucking a string was governed by numerical ratios. Musical intervals can be explained by the ratios of string lengths. The vibrations followed precise mathematical laws, and this was a great mystery. And here's the thing, it is still a mystery today. This is how it works. This string is 90 centimeters long. If we divide it into two equal parts of 45 centimeters, ratio 2:1, and pluck the string, this is the octave. The frequencies sound naturally paired. If we divide it by 3, ratio 3:2. It also sounds like they are paired yet slightly directed towards a resolution. And if we divide it into 4, ratio 1:4, that is a perfect fourth. And the more complex the ratios become, the less paired they sound. It's fascinating that our perception of harmony is rooted in mathematical simplicity. Think about it.
I once had a dream. I was all alone at the top of a skyscraper in New York City in the middle of the night, and I heard wonderful music. It seemed to come from the sky, and it touched me so deeply I could hardly bear it. I looked up, and I saw stars and planets orbiting in circles in a kind of a cosmic clockwork in motion, and I seemed to be a part of it. This was a turning point for me. Since then, I have always wanted the dream to come back, but it hasn't. It made me wonder about the connection between universe and music. How can the physical laws of the universe inspire us to create music and arts? There really is something out there that we cannot see, but we know it's there. What is it? I later found out that my dream was similar to Kepler's Music of the Spheres. He thought that planets are moving according to mathematical harmonies, producing a kind of cosmic music. While this music isn't audible, Kepler saw it as evidence of the beautifully ordered cosmos.
Harmony talks to our mood, but it is built up with very complex mathematical formulas. Heinrich Hertz replaced Pythagoras' focus on string lengths with frequency. Overtones naturally create a hierarchy of notes called the harmonic series.
The first harmonic is the main pitch we perceive in the harmonic series. The second harmonic, first overtone, is an octave above. The third harmonic, second overtone, is not an octave but a perfect fifth above the second harmonic. The fourth harmonic, third overtone, is another octave above the second harmonic.
It continues up, and different instruments have variations in amplitude, presence, and distribution in these overtones, giving them their special characteristics.
The first note in the series is like a massive gravitational centre with other harmonics orbiting it. At first glance, musical gravity and physical gravity seem unrelated. One is a force of nature pulling objects toward each other, while the other is an abstract feeling in sound. Both involve attraction, stability, and a return to equilibrium, making them deeply connected at a fundamental level.
I am endeavoring to re-experience the dream, but the experience of listening to the cosmic clockwork is not so direct it might seem, as out there is no sound. Sound is a mechanical wave and medium to propagate in, like air or water, but light is an electromagnetic wave. It can move from the vacuum of cosmos, and that is why I can see all these billions of stars. Some of them may be hundreds of thousands of light years away. If a massive gas cloud or a plasma field acted as a medium in space, sound waves would exist and still obey the same mathematical laws as we observe on Earth. Sound is just one expression of a deeper, universal mathematical reality.
There is a number woven into the fabric of the universe, a ratio whispered by nature, guiding the growth of petals, the spirals of galaxies, and the very structure of life. If you have a line and divide it into one longer and one shorter part and call them A and B, then make the following equation. A plus B divided by B equals A divided by B. The result is the Golden Ratio, also called Phi. Some call it the divine proportion. The ratio is about 1.62, but the exact value is impossible to find because it is indivisible. Computers have counted up to trillions of decimals, but not found the exact value. And no repeating patterns of the numbers have been observed. If you draw a rectangle of the proportions of A and B and make a perfect square within it, then you have a new rectangle of the same proportion. Then you draw another square, you get a new square, then another one, and so on. In here you can draw a logarithmic spiral. Yes, this is the equation of eternity, and it is fundamental to all existence. And it never ends. If you take the number 1, add 1, which is 2, and then add 2 with the previous number 1, which is 3. Then you add every number you get with the previous one. Then you will get a number sequence, the Fibonacci sequence. Like 1, 2, 3, 5, 8, 13, 21, and so on and so on. It spirals out in an eternity.
The petals of plants are always in a Fibonacci number. In that way, they will always have an optimal exposure to the sun. The DNA molecule aligns with the Golden Ratio, particularly in its helical geometry, allowing for an efficient, stable helical structure with self-replication efficiency. The growth of the shell follows a Fibonacci pattern where each new chamber expands in a way it keeps the same proportion as the previous one. In this way, it's making her shell more resilient to pressure and impacts and secure an efficient growth without shape change. The arms of the galaxy expand outwards, which closely follows the Fibonacci sequence. The shape distributes mass and gravity evenly, which is essential for the formation of new stars. The hurricane forms a golden spiral due to the conservation of angular momentum. It allows the storm to form without collapsing inward too quickly and to maintain pressure distribution. There are many more examples in nature. In aesthetics, Leonardo da Vinci frequently incorporated the Golden Ratio into his paintings to achieve aesthetic beauty and visual balance.
In his anatomy study, The Veruvian Man, he illustrated how the human body conforms to the Golden Ratio. The distance from the navel to the floor and from the navel to the head is approximately 1.62. The ratio of shoulder width to arm length and length of the hand compared to the forearm also aligns to the Fibonacci sequence. And in the face, the distance from the nose to the chin versus the nose to forehead and many other proportions follow the Fibonacci-based spacing. The human eye naturally finds phi pleasing and balanced, and a person with almost 100% the perfect golden ratio would be very attractive. Look at the piano keyboard. It is organized in groups of 2 black keys and 3 black keys, which makes 5. And then a number of 8 white keys, which is 13 altogether, all Fibonacci numbers. And then it spirals out to a new octave. Arpeggios are the sonic spirals of music, expanding mathematically in both directions. And what is the practicality of this? If you look at the anatomy of the hand, it might give a clue. The phalanges of the fingers and also the palm to finger ratio also approximates the golden ratio. Our physiology is designed to interact with instruments. In the realm of quantum mechanics, a system of waves or particles exist in a superposition where all possibilities present at once until observed. There is no difference between waves and particles. sound too can exist in a chaotic state, undefined and uncertain. We cannot hear this realm, but we can prove that it's there, as the logic of mathematics can tell us. In this realm, the sound does not sound the way we would expect it to. This is how it sounds in a chaotic world before we observe it. At the smallest scales, sound waves do not have definite relations or speeds until we measure them. Instead, they exist in a cloud of probabilities, oscillating more like waves of possibility than organized harmonies. This noise contains endless possibilities. At the moment we listen, it transforms noise into order. In that moment, the infinite possibilities of sound collapse into harmony. Just as quantum measurement defines a wave's reality, perception shapes music we hear, proving that consciousness itself is a harmonic process, and the act of listening emerges from a sea of potential brought into being by the very act of perception.
So why is the universe organized in such a mathematical and harmonious way? Does this point to a deeper intelligence, a fingerprint of God? The universe seems to follow mathematical laws with astonishing precision. The laws of physics are based on mathematics and equations like Einstein's relativity theory, Schrödinger's wave function, and Isaac Newton's laws all describe reality using numbers, or other laws of universal constants like the speed of light, gravitational constants, and Planck's constant. All have precise values that allow life to exist. And in geometry, mathematical patterns like the Fibonacci sequence and the Golden Ratio. Exploring music theory through the lens of physics has opened a much wider perspective. Music is not merely a selection of frequencies, it's a deeply ordered system that resonates both emotionally and intellectually. Likewise, physics is more than just equations. It's a poetic framework that reveals the hidden patterns of the universe. It's not only about how things work, but how they feel, and the profound sense of meaning we gain when we uncover the interconnectedness of our enigmatic world. But how far down the rabbit hole should you go? I was not prepared to go very far myself, but being intrigued by a single dream many years ago, I started contemplating things like why silence between two notes could say more than words, and how a song could stay in my head for days. But I didn't think I needed physics to understand it. I resisted it. but the more I learned about the vibrations, the frequencies, the resonances. They weren't stripping the magic away, they were revealing it. Until I found myself wondering something deeper, something unsettling, even exciting. So how far down the rabbit hole do you want to go?
Some say it's better not to ask. Why dig deeper? Music is just music. It plays, we nod, we move on. Why twist it into questions? Why burden it with physics, with consciousness, with mystery? Life is already full of riddles. Must we chase another? But some of us can't help it. Because maybe, just maybe, music is a clue. A whisper from the cosmos, a shimmering thread woven into the silence. And if we dare to follow it all the way down, we start to see rhythms beneath rhythms, echoes in our cells, harmonies humming in the architecture of thought itself. Maybe the rabbit hole doesn't lead to confusion, but to clarity, to awe. To a sense that we are part of something far more beautiful, intricate and interconnected than we had ever imagined. Perhaps we are part of the design.
Maybe math is just the best language for describing reality, but the reality itself is not necessarily designed. Many thinkers see the universe order as evidence of a higher intelligence, like Plato, Pythagoras, and even Einstein did. If math and music exist independently of human minds, could they reflect the thought of a greater mind? Others believe that math is not a proof of a creator, but simply how the universe works. The universe may be mathematical by necessity, because only structured systems can exist. We humans may only notice the order because we evolved within it. If the universe were chaotic, no intelligent life would arise to ask its questions. Whether or not the universe is the work of a divine mind, its deep mathematical beauty is something extraordinary. Music, numbers and physics seem to connect everything, from atoms to galaxies to emotions. If there is a fingerprint of God, maybe it's in the fact that we can even ask this question at all.